Hey everybody, this is a video that goes along with the greenhouse effect lecture tutorial. By now, you should have completed numbers 1 through 11 on pages 105 through 107. If you have not done that, stop this video right now and go back and complete those. Okay, I'm going to give you a really quick overview of some of the important answers, and then we are going to go on and do the rest of the lecture tutorial together. But first, I want you to actually take the time and effort to go through numbers 1 through 11 on your own. That information, all of this information, will be on the test. So do that and then come back and watch this video. In addition, tomorrow I will post the answers. So be sure to check your answers because I'm not going to go over all of them. Okay, so when we're looking at numbers 1 through 11, we start out looking at this graph. And what I want you to notice here is that most of the light is put out at two wavelengths, visible and infrared. So this is energy output from the sun. Visible and infrared, 44% plus 48%. That is most of the light. So the majority of the energy comes from those two. It does not come from ultraviolet. See, 7%, that's hardly anything. Even though this peak is rising, this tiny section isn't even close to being what visible and infrared give off. Okay, so that's one important thing. Ultraviolet light is not an important energy source when we're thinking about heating the earth, just visible and infrared. Okay. So then you should have seen this little guy, and what's important to note here is what's going on with the different molecules. So we saw similar graphs to this in class when we talked about telescopes. What you need to see here is these numbers represent absorption. So if it's 100% absorbed by the atmosphere, the line will be up here. If it makes it all the way through the atmosphere, the line will be way down here. Most of visible light makes it through the atmosphere. Most of ultraviolet light does not. And then you need to look at the molecules responsible for absorption. Again, our focus is going to be on visible and infrared. So if we look at the types of molecules responsible for absorption, we see things like carbon dioxide, and water. Okay. The other molecules that we're not really going to talk about with a greenhouse effect are oxygen, ozone, O3. Those are bad for other reasons. You may have heard of there's a hole in the ozone layer, right? That is separate from the greenhouse effect. Ultraviolet is absorbed by ozone and oxygen, but oxygen or ozone is not a greenhouse gas. These guys right here are our greenhouse gases. So with that information, we can move forward and kind of think about what's going on with our atmosphere and with the sun that's coming in. So you can fill in that. Okay, so you have this, and sort of the questions 8 through 11, and then 12 and forward, we're kind of thinking about this. And so I don't have a picture to show you for numbers 8 through 11, but what I want you to do is sort of think through that, and this can help you with that as well. Think about temperature, right? Think about even the temperature of your body. What kind of light do you give off? Okay, so your temperature is about 100 degrees. You give off infrared, right? You're not hot enough. You're not as hot as the sun to give off visible light, right? Think about the surface of the earth. Even at night, when you go out after the sun goes down, what's happening? If you have light emitted from the Earth's surface, is it going to be visible light? No, because it's dark. But you put your hand on the Earth and you're going to feel heat. So you're going to have some infrared light that comes up from the Earth, even at night. Okay, so think about those things, night and day, just kind of make it physical. Think about what you've actually experienced, right? And then we also, for number 11, this is an important point before we go on. Number 11, it talks about light given off by the Earth's surface. Will it get back through the atmosphere or not? Well, if the light given off by the Earth's surface at night, right, think about it at night. You can think about it during the day too, but at night, it's the infrared light. Same during the day. You put your hand on the Earth and it's hot. So you have this infrared light, but it's going from the surface back up through the atmosphere. It's still going to be absorbed. Just because it's not coming down, because it's coming up, it still has to pass through the same water and carbon dioxide molecules to make it back up to the surface. Okay, so now we have all the pieces and the parts to think about this figure and then to fill in the boxes on the last figure. Okay, so starting with number 12, we're going to kind of talk through these, and mainly we're going to fill out figure 4, but I'll sort of talk through the others to get us there. So number 12, how does the total amount of energy coming from the sun, okay, total amount of energy coming from the sun compare to the total amount of energy leaving Earth to go to space? Okay, so looking at number 12, total amount coming in, and the numbers here are just for your reference. So if you want to sort of think about it numerically, you can, and you can actually add them up too. I'm not so worried about the numbers. I just want you to get the big ideas. So this is the amount coming in, 342, right? Now, how much energy is leaving Earth and going into space? So we want to look at what is going directly out into space, right? There are our numbers, and if you want to add those up, we got 30 plus 77, right? 30, 77 plus 40 plus 195. Okay, I didn't even have to really pay too much attention to what kind of energy it was. We'll get to that later. Right now, I'm just worried about what comes in, 342, and what goes back out. We add this up. Guess what? 342. Okay, so all I'm doing is comparing this one arrow that comes in to the arrows that actually make it back to space. We're not worried about what's happening in the atmosphere quite yet. And they're equal. Interesting, huh? This is that energy balance that we talked about. The amount of sun that comes in equals the amount of sun that goes out. That is still true for our atmosphere, for the Earth as a whole. But what's the greenhouse effect is, what's different is what's happening down here in this gray part in the atmosphere. Okay, that's where we're going. That's what we want to understand. Okay, number 13. What type of light primarily heats the Earth's surface, and where does this light come from? And then same question for the atmosphere. So let's look at the Earth's surface. Here, I'll switch my color so I can do a different color. So let's look at, oh no, here I'll do green for the Earth's surface. For the Earth's surface, that's what we're looking for here. The Earth's surface, and Earth's surface. We're looking for, in this case, light that heats the Earth's surface. So we need now to look at the arrows. We want the arrows that go down towards the Earth's surface. So we have two of them. We have this one and we have this one. Where is this light coming from? Well, look where the arrow starts, right? This arrow, it's coming from the sun and going here. This arrow kind of starts up in the atmosphere and goes down. So we need to think about what kind of light it is. Go back to the first questions and the other graphs that we looked at. Remember, we're mainly thinking about visible and infrared, right? We said ultraviolet wasn't really a big source of energy. Same thing for the atmosphere. Think about the atmosphere. Those are the arrows here, right? Here's an arrow. Things that are coming into the atmosphere. Again, visible and infrared. I'm not going to spend a lot of time on this one because we're going to fill out the next picture and then we'll get into the details of it. Okay, so number 14 is more energy absorbed by the Earth's surface in the form of light coming from the sun or from light emitted by Earth's atmosphere. And why? Okay, so energy absorbed by Earth's atmosphere. So we need to look at those, and we're looking at Earth's surface again. Remember, here's Earth's surface was this one, and Earth's surface, we want energy absorbed, right? Absorbed by Earth's surface. I'm just looking for those words. And now I'm going to compare the numbers. So this is where the numbers can help you again. 342 and 168, I'm sorry, 324. 324 is greater than 168. So that means the energy emitted by Earth's atmosphere is greater than the amount that comes from the sunlight. Okay, that's how I answer that. So more energy absorbed by Earth's surface from the atmosphere than from the sun directly. Okay, 15. So this was number 14. This one was number 13. Okay, that looks like a B. Number 15. Due to the light absorbed by Earth's surface that was emitted by Earth's atmosphere, is Earth's temperature near the surface going to be warmer or cooler than it would be without this absorbed light? Think about that one for a minute. I think that I'm going to leave that one for you to think about so we can fill in the boxes for number 4. Okay, so I think one thing that'll help us, we're going to go on to the next picture, is to think about what kind of light that is. So number 15, the light absorbed by Earth's surface is coming from Earth's atmosphere, but what kind of light is it? Is it visible or is it infrared? And so to fully answer number 13 and to make connections with all of these, let's fill in this figure together. Okay, so here we go. I want to think about this in 3 different ways, just to kind of walk you through it here. So I'm going to kind of divide this up into 3 little chunks here. First chunk, we are going to look at what is coming from the sun. Okay. So we know from the very beginning of this lecture tutorial that the sun emits ultraviolet, it emits visible light, and it emits infrared light. We said ultraviolet wasn't that important, but it is part of what is emitted. Okay, so we have all these things coming in. Where do they go? Right? To answer this question, I'm going to go all the way back here and I'm going to say what gets through and what doesn't. Ultraviolet, does it get through the atmosphere or not? Visible, through the atmosphere or not? Same for infrared. Okay, let's go back. Here's our boxes. We have ultraviolet, visible, and infrared getting through. What makes it all the way through to the surface? What makes it all the way through is visible light, right? We have our telescopes on the Earth's surface. What doesn't make it through? What gets absorbed by the atmosphere? That's the ultraviolet and the infrared light. It doesn't make it through. It stops right here. Think of these arrows as this is the stopping place in the atmosphere. right? And this is, oh, atmosphere, and this is the stopping place on the surface. Okay. What about these two, the ones that go back into space? Well, if ultraviolet and infrared kind of get absorbed or stuck in the atmosphere, then really it makes sense that visible light is going to go back out. So visible light comes to the surface and is reflected back out to space. This is why you can see the Earth, right? You can see the Earth while you're standing on it. You can see the Earth if you're in a spacecraft above it, because visible light goes back out to space. Same is true that visible light also is reflected by the Earth's atmosphere. I think sort of the best way to think about this is clouds, right? All that light gets reflected back off of clouds up into space, all right? Not really our point for today, but interesting anyway. Okay, so now we really then need to focus on this part. What's going on in the atmosphere? Because it's all about the greenhouse effect again, y'all, right? Okay, so here we go. Next one, we'll do red for this one. Next, we need to think about where does the heat go and what's happening and all of that. So this next section, I'm going to call this heat from Earth's surface. What's happening to it? Because we had this visible light come in, it's getting absorbed by the Earth's surface. That's going to cause the surface to heat up, right? We got heat here. So now we have this hot surface. What's going to happen to that light? If you have heat here on the surface, it's going to emit heat. Infrared light is going to come out of the Earth, and it's going to go two places. It's going to go directly out into space, some of it, but most of it, right, look at the big number here, is going to get absorbed by the atmosphere. Greenhouse effect. Okay, so heat from the surface goes into the atmosphere, and it's infrared. Remember, the Earth is not putting out visible light. Visible light is reflected, but the Earth doesn't make visible light, okay? Now we have to add in a piece of heat from the atmosphere. Try to spell atmosphere right this time. So these first two parts, let me go back a second. These first two parts, this is that energy balance that we talked about. Heat coming in, light coming in, visible light coming in equals the heat coming back out. So that's that energy balance. This part, heat from the atmosphere, this is the greenhouse effect part. I should have picked green, huh? This is the greenhouse effect right here, this section. This section says that we now have heat trapped here. Heat trapped by greenhouse gases, carbon dioxide, and water, and in the form of infrared light. And it's trapped there. Look, here's infrared, here's infrared. It's all sitting there in the atmosphere. And it can go two ways. That heat can go up and out, or it can go down to the Earth's surface. This little piece right here, where heat goes down to the Earth's surface, is really what we're talking about with the greenhouse effect. If we did not have the greenhouse effect, we would not have this last little bit of the cycle, and Earth would be colder and Venus would be colder, because all we would have was this part. By trapping the infrared in the atmosphere, we get extra heat going back to the Earth's surface, and it gets even hotter than it was before. Okay, so this little graphic here is a summary of the whole lecture tutorial. It's also a summary of the greenhouse effect. If you are going to study something on the greenhouse effect, this is a good way to do it. Okay, think about it in these terms. What is absorbed? Where? Infrared is absorbed by the atmosphere. it is sent back down to Earth. It heats the Earth's surface even more. All right, and then finally, number 17, you've got the little student conversation. I'll leave that to you guys. Be sure to check your answers. All right, so I skipped a few, I bounced around, but if you look at this picture, check your answers, you should be good to go. All right, have an awesome day. I will see you all on Friday.